Distance learning curricula in machine learning. Main categories of machine learning. Good afternoon and welcome to the machine learning course. This course was developed as a result of the Erasmus Plus project Code-In. All you need to learn is internet access and a computer. The course contains a total of 10 topics, and in this topic, we will say something more about the main categories of machine learning. An algorithm is a set of instructions or rules that a computer or machine follows to perform a specific task or solve a problem. In the context of machine learning, algorithms are used to enable machines to learn, reason, and make decisions in a way that mimics human intelligence. Machine learning has been a field of study for decades, with researchers and engineers constantly working to develop new and more advanced algorithms that can enable machines to perform increasingly complex tasks. The goal of this research is to create machines that can truly think and act intelligently, like humans. In order for a machine to learn, it must be provided with some form of input, such as data or information. This input can come from a variety of sources, including voice commands, data files, online searches, or electronic measurements. The type of input and method used to acquire knowledge will depend on the specific task or problem that the machine is trying to solve. Machine learning algorithms can be divided into different categories, with two of the most common being supervised learning and unsupervised learning. Supervised learning is a type of machine learning where a model is trained using a labeled data set, which means that the desired outcome or label is already known. The model is then able to predict or classify similar instances based on the patterns it learned from the trained data set. One of the key characteristics of supervised learning is that it requires a training data set, which is a set of data that has already been labeled with the desired outcome. This data set is used to teach the model how to make predictions or classifications. However, it is important to note that there may be situations where the initial data set is not sufficient to achieve the desired level of accuracy. In such cases, additional data may need to be gathered to improve the model's performance. Independent data, also known as predictors, are the input variables that are used to make predictions or classifications in a supervised learning algorithm. They are independent of the desired outcome or label and are used to determine the value of the dependent data. Dependent data, also known as the target or outcome, is the variable that the model is trying to predict or classify. The value of the dependent data is dependent on the independent data, which is why it is called dependent data. In other words, the independent data is used to make predictions about the dependent data. In summary, independent data and dependent data are two important concepts in supervised learning. Independent data are the input variables that are used to make predictions or classifications, while dependent data is the variable that the model is trying to predict or classify. The value of the dependent data is dependent on the independent data, which is why it is called dependent data. In the scenario of applying for a bank loan, the independent data would be the criteria used to determine if the loan will be successful. This could include factors such as the applicant's credit score, income, employment history, and debt-to-income ratio. These independent variables are used to make predictions about the outcome of the loan application, which is the dependent data. In the case of the loan application, the dependent data would be whether the loan is approved or not approved. The value of the dependent data is dependent on the independent data, which is why it is called dependent data. The model uses the patterns learned from the training dataset to determine the probability of the loan being approved or not approved based on the independent data. Another example of supervised learning is an anti-spam filter as a tool that predicts whether an email is spam or not. The filter initially starts with a basic guide, but as the user gives responses, it learns what the user wishes to label as spam, thus reducing the number of questions asked. Over time, the user trains the algorithm to improve with the help of known inputs like email. Overfitting, the peril of tightly fitting a model to training data, hampers its ability to generalize to new unseen information. The key lies in achieving a delicate equilibrium between flexibility and accuracy. Models must be capable of adapting to diverse data while making reliable predictions. Therefore, it is crucial to avoid excessive rigidity or excessive accommodation of training data idiosyncrasies. By striking the right balance, models can navigate uncharted territories, uncovering underlying patterns and propelling the field of machine learning forward. Unsupervised learning beckons us into a realm where data structures remain mysterious, awaiting our exploration. Data defies classification and labels here, presenting a blank canvas for algorithms to draw insights from expansive dataset. These algorithms embrace the challenge of deciphering hidden patterns and structures stripped of labeled responses. With unsupervised machine learning, two main categories emerge: clustering and dimensionality reduction. Clustering unravels the tapestry of data, uncovering inherent groups and clusters, while dimensionality reduction distills complexity, revealing the essence of the dataset. Together, they empower us to embrace the mysterious world of unknown data, where untapped knowledge and discoveries lie in wait. Imagine you have a dataset of customer transactions from a grocery store. The data includes the items purchased and the time and date of each transaction. Using unsupervised learning, you can perform clustering on this data to group customers who have similar purchasing habits, such as those who consistently purchase certain items or those who make purchases at similar times of day. This information can be useful for the grocery store, as they can target their marketing efforts towards specific groups of customers and even stock items that are popular with certain groups. This is an example of how unsupervised learning can uncover hidden patterns and relationships in data without the need for explicit labels or guidance. To complete this unit, study and review the following online resources. Thank you for attention.